Okay, guys, back at it. In order to remember where we've done eliminations and stuff, I have marked it with a white piece of tape. Now, we can set that aside. Moving on, this is our IPR sensor that we replaced. IPR plug, excuse me. In with this gang of wires is the fuel bowl connector that connects, the fuel bowl harness connects into this plug. How do we know that? Well, that's pretty straightforward. Here is the fuel bowl harness. We get the heater and let me get a real pointer instead of my finger. We got the heater and the water and fuel sensor. Now it comes along this connection at B. If you go back to the drawing 27.3 and go to B, it's a power on. It's just basically a 12 volt connection. And that is why when this heater pops and goes to ground, as in a lot of times they do, you'll blow that fuse and you get a no start because you go to the powertrain module and without the power going through, it doesn't start. So that is C, as we were stating earlier, C1076. And when you're on this page, like I was saying before, you get to pick connectors if you want to look at them. Well, this is C1076. Now it's it's white. It's a 2-pin connector, and it's got red with a light green stripe and gray with a red stripe. So here we are, red with a light green stripe and gray with a red stripe, and it's a white connector. Easy to identify the circuit. And the best solution for these is to clip them and encase them in heat shrink. Just leave them hang, because if they can't short against anything, that'll be fine. And you don't need it anymore because we're eliminating the fuel bowl with our regulated return system. Now, I've been doing a ton of research on, that's not it, this one, no, this one, the exhaust back pressure switch. Now the way it's an interesting system. The way it works is you've got, that screws into a fitting on the front cover where the camshaft cover goes. I'm sorry, the high pressure oil pump where you put the bolt in to secure the gear. And it goes in a bracket there, and then there's a tube that goes down to the exhaust manifold, the right hand exhaust manifold. Well, what this circuit is supposed to do, it not only controls the EPV, which is the valve that's in the pedestal, it also has direct influence on the fuel mapping. So that is a variable capacitor circuit that'll vary the voltage sent back to the computer. It's a 3-pin connector. You've got a 5-volt reference, a 5-volt, well, it's the variable part, and then you've got the other end of the circuit, which goes back to the computer. So you just can't clip it and leave it. But we can still eliminate it. Because from what I've read, it doesn't make much difference if you leave it plugged in and disconnect it from the exhaust manifold. Because we certainly don't want it affecting our new build. And it can, because what it actually does is it detects back pressure. As back pressure builds, it starts to change the fuel table, and it actually defuels your engine to keep you from blowing stuff up. Well, we've got a T4 turbo kit, which is going to push a whole lot more pressure, hence more back pressure, hence the 4-inch exhaust and everything else, all the other mods needed to compensate for that. Well, there's a good chance you're going to get an overboost. And we're going to put a boost fueler in it too, on the map side. But we don't want this one, this sensor, affecting the fuel tables. Because that's all you need to do is be pulling a big, this truck's being built for pulling heavy loads. All you need is be pulling a heavy load up the side of a mountain and it defuel the engine because you're overboosting. That would be disastrous. And I'm not sure, but I think that's what happens to a lot of hotshot truckers that run 7.3s. This tube will get partially clogged. It'll send misreadings to the computer, and the computer starts to defuel the engine because it thinks it's in an overboost, which is an interesting problem. All you guys running 7.3s that are pulling heavy loads should probably check that tube, or do like I'm going to do. I just put a plug in the manifold because it's nothing but a 1/4-inch pipe plug. I plugged it, pulled the tube out, and we're just going to let this switch. I'm going to go to the Ace Hardware and get a cap for it, and we'll let it hang in the harness. We'll reroute it and hang it to something. Maybe even a heater hose that right next to it where it's connected. That way we don't have to redo a whole bunch of harness work. So it's an interesting problem, and it's an interesting solution. And from what I've read on the interwebs about that solution, it's the best one. Because if nothing else, this will be at 1 atmosphere. In other words, 14.7 pounds is 1 atmosphere, PSI. And if you cap it, it stays at 1. So you're on that fuel table. I don't think that's going to be a problem because we've got different injectors in it and we've got a different turbo in it. So the fuel tables that are originally in the computer probably aren't going to matter much. We're going to be running off the tunes. That's what the tunes is for. However, I don't know if the tunes compensate for this switch. They may not. We may be barking up a dead tree where the tunes are going to take care of this and we don't even have to worry about it. But just in case it doesn't, we'll have it in line and it'll be sitting at 1 atmosphere, which ought to make it run okay. From what everything I've read, guys have been running it for years with it just hanging in the harness like that and never had any problems and never experienced any lack of power. So it seems like a viable solution. So we'll go with that. But in the meantime, we're going to eliminate this one. And I think we have one more to eliminate. I'll find out. But here's all our dead plugs. Kind of interesting that they're just kind of collecting dust now. We've replaced 4 of them already. I didn't realize we were replacing that many. So, let me get the soldering iron heated up and we'll continue on. Okay, I've cleaned these 2 wires all the way back to this point, which will be good enough. Let's clip them. And that's another dead connector. Now we just need to slip it partially on and heat shrink it. And that'll seal that wire. I can find it going. Here we are. And like I said, once the glue popped out the end, it's sealed. There's not going to be any moisture getting in that wire. And it's glued onto the end of the wire also. I'll make sure you can see that. Let's pull it a little closer. There. You can see the glue dripping out the end of the heat shrink, so we can be guaranteed that that is a watertight connection now. And isolates that wire. Let's do the same with the other one. Try to stay out of the way of the camera here. Slid down some. Whew, that thing's hot. And there comes the glue. Alright. I'll let those cool. Stuff. That's why I was holding off on wrapping this one. This is our new IPR connector. And we'll just include that in the harness and just drag them down through there. And they'll be isolated. And that eliminates all the fuel bowl stuff from the old from the old build. The original build, excuse me. So I'm going to pause it while this cools, and then we'll just put that in some harness. Alright, so moving along. Put these back in the harness. Very good. And now we're going to use a piece of this. Hey, look at that. It's almost like it was made for that. So I can get it open. This stuff is so hard to work with. A friend of mine redid his harness and used the mesh type stuff. Oh, it looks so nice. But, well, that's interesting. I guess we could tape it like that, but let's see if we can get it inside. That's actually just heat shrink. There we go. Very good. I think we'll leave that case like that. Very good. All right. So we can tape that one up. We've actually done quite a bit of, you know, I thought this harness was in good shape, but we've actually done quite a bit of work on it. There we go. Alright, that keeps the end closed. I'll just do this little transition and this part's finally done. And once again, this will get a piece of white tape where, because we've done a elimination on it. All right, cleaning it up, look good. Okay. I think this is the boost solenoid. I gotta check. It might be the air heater. I'm not sure. Let me look it up. We'll move on. Okay, I've got a couple feelers out for what other guys have done with this boost control solenoid switching. So we'll see what they say. And I've also got some emails out to vendors to see what they say. It's an interesting problem because if you don't do it right, you can suffer some defueling. So we'll see what they say, and we'll include it in one of these videos. We're going to move on now. Okay, guys, I've collected a bunch of data on this EPV sensor. There's a couple of different ways to handle it. One is to tie it up like this, cap it, and strap it to the harness somewhere so it's out of the way. The other one is to actually run the tube and let it do its job. I'm debating on which one to do. I've got a plug in the manifold right now, but I still have the fitting. I've got the new tube. I cut the ear off the cover for the camshaft bolt, so I'd have to get a new cover if we wanted to go back to running it. And there's different opinions on it. A bunch of people that responded to me said just leave it hanging. Well, that's going to set a soft code. Several people replied to me to do this. Just, that'll take an 1/8 inch pipe plug on it and just strap it up. And then other people say just install it, let it do its job. So I know I'm repeating myself, but I don't know. Anybody running a T4 out there? Let me know what you're doing. It's an interesting problem, and there's not a lot of really good data on how it affects tuning. It does map voltage to back pressure through some kind of algorithm. Not sure. It's got to be resistance because it's basically a thermistor. It may not be a thermistor, maybe a pressure switch, but it's variable. And if it's a pressure switch, they'd be using a capacitor. If it's a thermistor, they'd be using a resistor. So can you put something in and tune it? I suppose. It might be the best method to just leave it run and have to clean it every 50,000 miles, because it will get plugged. I mean, that's just the nature of the beast. It does get exhaust soot in it. Or you can run it this way, and I think we're going to run it this way and see how it runs. We can always put the tube in and all that later if we have to. It'll be a pain in the butt, but we can do it. Because I think capping it will keep it at 1 atmosphere, 14.7 pounds of back pressure, which actually could equate to 0. I don't know the chart. I don't know how it's mapped. But these engines are only good for, a race engine put 50 pounds of boost on it. This one's not going to. This one will max out 28 to 30, somewhere in there. And we're going to have to put a boost fooler on that to keep from setting a code on that. So you're starting at, I guess, 0 would be atmospheric pressure. We'll see what it does. In the meantime, we're working our way down through the harness. I'm going to take this rubber seal off and clean this all up, unwrap it, check it. Let me get that done and we'll get back to it. On my 96, when this got all soaked with oil, it actually dissolves the wires and makes them into goo. And it was actually shorting against the RF shield. And the RF shield is grounded. So you had every time it would fire an injector that was laying against that shield, it would just ground it and not fire the injector. Which can be a problem, I guess. Well, I'm not going to bore you with getting this clean. Let's pause it and we'll get this clean and then we'll continue. Alright. That is now pretty clean. I didn't even clean anything in here, but check it out. It's clean. It's in good shape. Let's plug her in and check wire connectivity. This is that jumper I made for doing exactly that. Set up a alright. Now we'll check these out. And it's like we said, these first two outers are glow plug, so you can go directly to the glow plug terminal, make sure they're connected. There's 2 for injectors, 1 ground, and 2 for injectors. So we'll dig out the schematic on the rest of them, but let's check the glow plugs real quick. That's 1 right there. That's good. That's good. That's good. That's good. This one here seems to be building resistance. Let's take a peek at that. Oh, no, that's good. Alright, so the glow plugs are good. Glow plug wiring, excuse me, is good. Let's get the schematic out and get the pin out on these injectors. Okay, here's our schematic for this side. Let's see. Our connector is C110, which is right here. So we've got a tan with red, a tan with black, the orange, brown with yellow, and a tan. And there's our terminal numbers. So we'll start at this end, I guess, as good as any. It's going to be a tan one, and it goes to terminal 2. So I guess that's tan. Oops. Yeah, that's tan. It goes to terminal 2. Terminal 2 is going to be that's across the harness. I don't know if that's in view or not. Let's see. It should be right there. Yeah, one's blank. This side. That's what it said. Two is tank. What is this tank? Oh, sure is. But that's not good. What's the next one? The next one over is brown with a yellow stripe. Yep. Brown with yellow stripe, and it goes in terminal 5. That's 2. Oh shit, wrong one. That was 2. Go back here. Alright, I don't know if you can see that. Terminal 2. Is that showing up for me? Yeah, there you go. Alright, that's the first one. The next one is brown with a yellow stripe. And that is, on here is, we go to our C110, which is right here. It's going to be terminal 5. So that's 2, 3, 4, 5. Yes, good. All right. Then we have brown, which is orange, which comes out to terminal 12. Go for 5, 9, 10, 11, 12. Alright, that's good. And the next one is a tan with a black on terminal 7. Tan with black. Okay, tan with black, that's correct. And it was number 7, so 2, 3, 4, 5, 6, 7. Yep, that's good. The next one is right here is terminal number 4, and it's tan with a red stripe. Yep, tan with a red stripe, number 4. 2, 3, 4. Alright, very good. Like I said, these harnesses are not very hard to work on. Then of course we got more glow plug. Then we go back to glow plugs, which we already checked. Alright, so that connector is good. We can tape it up and close it up. Make it ready to connect. I'm running short on tape here. I have to get some more. Leave it out of the way. Yeah, where's the tape? Yeah, we might have enough. Let's see. That piece was this right here. It's kind of short. I think it should be a little longer. Let me see if I can find a piece this size. Stand by. That size is 1/2 inch. Shopping. You can pick this stuff up at Harbor Freight. Pretty cheap. I know there's the nylon wraps and all that kind of stuff, but you know, we're not making a concourse vehicle. We're making a work truck, and this stuff, I don't know if it's more. It might be more resistant to abuse than the mesh type. I don't know. I haven't used the mesh type. Let's see. What do you think? Alright. Oh, right there. We can always cut more off. like the way that fits better. Alright. So let's put that back on. We'll start our tape wrap. Looks good. Now we'll just make a, that was a T before, so let's make it a T. This will be our last wrap. Don't have any more tape. Alright, that's good. And that one checks out. Now we have, that's all we have left is the glow plug stuff. And it just needs connections to be done. This one here is the heater, the air heater. It only comes on in certain conditions. While we're at it, let's put this seal on. I take the seals off to clean them because it's a lot easier to clean them. Okay. And it's got a half twist in it, which is very easy to do. There we go. Good as old. Has a good seal on this stuff, so they're good. Alright, like I said, all we got left is this glow plug. Let me unwrap it and see what we got. Okay, let's look at what we got here. We've come down to this connector. Everything in this leg has been checked because we've checked this end for connectivity all the way back to our plug. So we don't have to worry about it. The only ones we've got to worry about is these glow plug relay connections. And of course, that's battery. That's the closed terminal side. That's the battery side. And then you've got the two wires to energize the relay. So let's look those up on the schematic, see what we get. Okay, so here's our circuit for the glow plug relay. Two wires energize it. They are 24. No, that's not it. Although there's a splice and a splice there. Federal in California. Ah, yes, we don't have the California, thank God. That's that one. And then C110 terminal 13 is one side, and terminal 24 is the other side. So 13 is violet orange, I guess. And this one is just red. Okay, so let's find them. Red is 18. Let's try it. Let's find that one. 14, 18. 18 lists gray with red and red. Well, that's not right. Ah, wrong one. It is C110 pin 24. Okay. So this is the red one. And we need to go to pin 24 on our main connector, which there is up here. I don't know if that's in camera or not. Things are getting pretty far from the connector, so let's see what we got. Make that readable for you guys. Too much crap in the way. Let's see. 24. 21. There's the 1, 2, 3 row. 21, 22, 24. No. Okay, there's nothing in there. Let's see. Okay, it's the third one. Yeah, there it is. Okay. Alright, that's good. The other side of the coil is yellow with a black. No. The other side of the coil is, oh gosh, that one is red with a black, red with a stripe. Ah. Violet with an orange stripe. Okay, that red. Where's my end? Good Lord. Let's see. That is 24, which is that. Is it 13? That's 16 right there. 10, 11, 12, 13. Yeah, okay, there we go. Good. Hope you can see that. Alright. So our wiring is good back to the solenoid. Of course we know that because we were using the glow plugs before. We know the relay was closing. And I did purchase a White Rogers relay when I was diagnosing this truck, because the old one, half the time it would close and half the time it wouldn't, so it was bad. So move some of this crap out of the way. Let me clean up a bit here. So we'll wrap these ends here. Just to keep them closed, basically. About 3/4 times around is all you need. It keeps the loom from snapping open. This is a pretty busy part of the harness here. I don't think I can wrap that. I'll try it. So, you have to do some of these. I don't know if that was even in frame. You have to do some of these in pieces because they're so... This one has 1, 2, 3, 4, 5 connections. All within 2 inches. So you clip off pieces and try to cover as much as you can. And I was going to do this in the new braided type. loom cover. The self-closing braided. I like it, but I have this on hand, so if this one starts to give us trouble or the tape fails or whatever, we'll try one of the other stuff. I just get sick of waiting on parts and waiting on this and waiting on that. It gets kind of old. Let's get some stuff done. This one here, I don't think I'm going to unwrap this. It's only a single cable, and it's this. So there's no need to unwrap it. Same with this. We might just pull what's loose and secure it. But there's no sense in unwrapping that because it's one wire. And it's spliced here. And we already checked them for continuity, so they're good. But we can make sure it doesn't peel anymore by securing the end we just clipped off. Now we have the wastegate. We need to get rid of it. Where is he at? Let's see. I believe that's it. Yeah, wastegate. Alright. That goes the alternator. This is the wastegate. I think what we'll do is we're obviously going to get rid of the connector because there is no wastegate on this engine anymore. So let's we'll just clip it and seal it. Let's peel it back some. I'd say maybe an inch. Yeah. So let's cut these. We'll stagger the cut. Make sure they don't touch each other. I'll take a piece of it. Tubing. Let's clean those wires off so that they aren't dirty. I think this is our last one we have to do. Good, because I got other plans for today. Do some real work here. Well, this is real work, but you know, other than trying to get this project moving. Never have any time with all the kids and all the work I gotta do. Been working every weekend plus 5 days a week, so it doesn't leave a lot of time for really anything. All right, where's the heat gun? Let me get the heat gun. Stand by.